Why are complex optimization problems NP-hard for classical computers? Imagine trying to find the best route for a delivery truck that has to visit dozens of cities. The number of possible routes grows so fast that checking each one would take forever. That's what makes some problems so tough for classical computers. They call these problems NP-hard, which means no known method can solve them quickly as the problem gets bigger. As the size of the problem increases, the time needed to find the perfect solution skyrockets, often growing exponentially. This is why classical computers struggle with complex optimization problems like scheduling, routing, or resource allocation. They have to sift through an enormous number of options, and that takes too long. Think of it like trying to find a needle in a haystack, but the haystack keeps getting bigger and bigger. These problems belong to a class called NP, which means if someone gave you a solution, you could check if it's right pretty fast. But finding that solution in the first place is a whole different story. That's why they're called NP-hard, because they're at least as hard as the hardest problems in NP. Many real-world challenges, like planning airline flights or designing efficient circuits, are NP-hard. Classical computers have to explore countless possibilities, and that exploration takes so much time that it's often impractical. Now, this is where emerging quantum technologies come into play. Quantum computers use phenomena like superposition and entanglement, which let them process many possibilities at once. For example, quantum algorithms such as Grover's algorithm can speed up search tasks, offering quadratic improvements over classical methods. Researchers are developing quantum algorithms specifically aimed at tackling NP-hard problems more efficiently. These advancements could revolutionize fields like logistics, finance, and materials science, where classical methods hit their limits. Instead of trying to check every possible solution, quantum computers might find better answers faster by exploring many options simultaneously. In essence, classical computers hit a wall because the number of solutions they need to examine grows too quickly. Quantum technologies offer a promising way to bypass this barrier by changing how we compute and solve these tough problems. This shift could lead to smarter, faster solutions for problems that today seem impossible to crack within a reasonable time.